Hey guys, one more video for the week on chapter 3.5, the equation of lines. So let me just remind you that the equation of a line is given by taking y equal to mx plus b. At least this is the equation of a line in slope-intercept form, right? X and y are our variables. So if I was given, slope and the y-intercept, I could just plug those values right in. So if I knew that, say, there was an equation of a line, say let's give it slope 2, and say it passes through the point say 0, -5. Then this is the y-intercept. They're giving me the slope and the y-intercept. I can right away just say, well, y equals 2x minus 5 is the equation of that line. And that's fine. But the reality is they may not necessarily give me the slope. I may not be given even the y-intercept. So I could do something like given slope equal to, say, 6, and I want the equation of a line passing through the point 6, 3. Then I have some work to do, right? Because now I just know that y equals 6x plus b, but I don't know what b is. This is not a y-intercept, so I can't use b here. B is the y-coordinate of the y-intercept. 6, 3 is just some random point off in space. The nice thing is that they did give me an x and a y value, so I can use that to plug it in and find what b actually is. Meaning if I let y equal 3 and I let x equal 6, then I get that 3 has to equal 36 plus b, or if I subtract both sides from 36 from both sides, I get -33 equals b. So then I really know m, I know b. I can find the equation of the line to be y equals 6x minus 33. But what the problems that I really want you to focus on, and the ones I want you to see or try in MathXL today, give you 2 points and ask you to find the slope. So let me just say that first off, if you're given 2 points, usually we label them x1 and y1. So let's call the first point x1. Let's call the second point the second point x2, y2. So if we're given these 2 points, then the slope between them is found by taking y2 minus y1 over x2 minus x1. Remember that the slope is the rise over the run, so we have the y values over the x values, the change in y over the change in x. So you can remember this as rise over run again, being y2 minus y1 over x2 minus x1. So then say I ask you to find the equation of the line. With slope, or I'm not going to give you the slope actually. Let's just say find the equation of the line passing through these 2 points. Say 3, 0 and 4, 5. Sorry, 5, 4. Notice they didn't give me the slope then, they didn't give me the y-intercept either, but they did give me 2 points, and I have some way of finding the slope. So if I just come down here, I know this is an x value, I know this is a y value, I know this is an x value, I know this is a y value. I could label this first point x1, y1, and I could label this second point x2, y2. Then the slope of the line that contains both these points is given by just taking the difference. 4 minus 0 over 5 minus 3. So that the slope is 4 over 2, which is just 2. Again, just like before, that tells me then that the equation of my line is y equals 2x plus b, but I'm not done yet because I don't know what b is. The nice thing is, though, they gave me 2 points. I can choose my favorite one to plug in and find b. I might just use the one that has a 0 in it, so I might take point 1 and plug in its x and y value. I let y equal 0, I let x equal 3, and then I see that 0 equals 6 plus b, or b equals negative 6. Anyway, once you have the slope and the y-intercept, you can put your equation of your line. You can put your equation in slope-intercept form to be y equals 2x minus 6. Alright, so the idea is you always need the slope, you need the y-intercept. If they give you both, great, it's an easy problem. If they give you the slope and just a random point, you can plug that point in and find b. But worst case scenario, they give you neither. They just give you 2 random points that lie on the line. Then there's this nice formula for finding the slope of the line, and after you find the slope, you can use either one of those points to solve for b. Just be careful when you're using the formula. A lot of times, a lot of people make mistakes with negatives. So if I ask you to, say, find the equation of the line, passing through the points negative 6, negative 3, and negative 9, negative 2, so that there's negatives everywhere. Then again, notice that I didn't give you a slope, I didn't give you a y-intercept, I just gave you 2 points, negative 6, negative 3, and negative 9, 2. Negative 9, negative 2. So it's up to you. You can call whichever point 1, whichever one point 2. But just make sure this is point 1, so this is x1, y1, and this is point 2, so this is x2, y2. If you wanted to, you could totally call this point 1, and this point 2, it won't change anything, but x1 has to go with y1, x2 has to go with y2. So to keep from getting confused, I always go in order. Just call this point 1, call this one point 2. So that the slope is equal to, be careful when you substitute, it might be worth putting in parentheses first, negative 2 minus negative 3 over negative 9 minus negative 6. So that way I could see that, yeah, y2 and y1 were negative 2 and negative 3, x2 and x1 were negative 9 and negative 6. But more than that, I know I'm not going to make a mistake on the subtraction. This is really negative 2 plus 3 over negative 9 plus 6. So that I just get 1/3. That means then that my slope is 1/3. I'm kind of halfway there. I have y equals 1/3 x plus b. I just don't know what b is. And anytime you want to find b, you can choose your favorite point to plug in. Last time I plugged in, I think the last 2 times I plugged in the first point. So let me plug in the second point just to show you can choose any. If I let y be negative 2 and x be negative 9, I'm using the second point so that I have negative 2 equal to negative 3 plus b. Adding 3 to both sides gives me that b equals 1, so that y equals 1/3 x plus 1. That's the equation of my line that contains both points, and if I want to check, I could just check by plugging in both of the values, meaning if I plug in negative 6, 3, if I plug in negative 6 for x, then I'm going to get 1/3 times negative 6 is negative 2. Negative 2 plus 1 is not negative 3. I must have made a mistake somewhere. Oh, I know what it is. When I did my subtraction, negative 6 plus 9 is negative 3. So I should have gotten my slope to be a negative 1/3. All right, negative 9 plus 6 is negative 3, giving me a negative 1/3. So that this should have been a positive 3. Well, that way, when I subtract 5, I end up with b equals negative 5. So really, my equation on my line should have been y equals negative 1/3 x minus 5. All right, so then now I can really check. If I plug in negative 6 here, negative 1/3 times negative 6 gives me 2, and 2 minus 5 is negative 3. Or if I check using the other point, if I plug in negative 9 here, negative 1/3 times negative 9 is positive 3. 3 minus 5 is negative 2. So it works in both cases. Since I messed that one up, I'll do another one with negatives again. I apologize for that. So let's just say I ask you to find the equation of the line. Passing through the points negative 4, negative 3, and negative 8, negative 4. Again, my points are negative 4, negative 3, and negative 8, negative 4, so that this is my x1, y1, this is my x2, y2. I know the slope formula is y2 minus y1 over x2 minus x1. So I'm going to be very careful to plug in y2 is negative 4, y1 is negative 3, x2 is negative 8, x1 is negative 4. Oops, I don't know why I put a comma there. You subtract them. So that this becomes negative 4 plus 3 over negative 8 plus 4. Let me be careful with my subtraction this time. I get negative 1 over negative 4, which is a positive 1/4. So that the equation of the line looks like y equals 1/4 x plus b. If I knew b, I'd be done. I don't know b, so I choose a point to plug in. Again, either one works. I'll stick with point 2 since I messed it up last time again. Negative 4 is equal to 1/4 times negative 8 plus b. So that if I multiply 1/4 times negative 8, I get negative 2 plus b. And if I add the 2 to the other side, I get negative 2 equals b. So that y equals 1/4 x minus 2. And then again, if I want to check, I plug in negative 4 for x. That gives me negative 1. Negative 1 minus 2 is negative 3. If I plug in negative 8, I get negative 2 minus negative 2. That is 4. So it works in both cases. Then this is the equation of my line. All right, so the problems are available on MathXL. Make sure you check them out. Give them a try.